In this presentation, we are going to look at the binomial distribution. We are going to use statistical tables in this instance. Okay, so suppose a signal of 100 bits is transmitted and the probability of sending a bit correctly is 0.9, while the probability of at least 10 errors, exactly 7 errors, and between 5 and 15 errors inclusively. Okay. So just to start off, what we're going to do is look at this table. So statistical, Murdoch-Barnes statistical tables, and what this tabulates is for some binomial coefficient where n and p are specified in the tables. This gives us the probability of x being greater than or equal to some value k, where k is these numbers that we're interested in. Okay, so I just sort of getting ahead of myself here. What we're saying is that the number of independent trials here is 100, and the probability that we're interested in is 0.1. Now, where am I coming up with this 0.1? Surely we're told 0.9. Essentially what we're doing there is that we're just flipping the definitions of what is a success and a failure. Okay, so an error in the context of the binomial experiment, that is our success, and the probability of that success is 0.1. So that's what we're interested in. Okay, so the first question is, since the probability of success is 0.9, we consider the distribution of the number of failures. Okay, and that is our definition of success. We reverse the definition of success and failure. Success is now defined as an error, a bit sent in error. Okay, a little bit hard to get your head around that when you get used to this stuff at the start, but it's just two events. One is the success, one is the failure. Typically, the success is the possible outcome that's less probable. Okay, so the probability that a bit is sent incorrectly is 0.1. So first off, we should always state this: let x be the total number of errors. Okay, and x is a binomial random variable with n equal to 100 and p equals 0.1. So just a sort of statement like this, just to actually sort of start off, is always useful. Okay, when you're writing your exam paper, probably a little bit more than I wrote there, but you know. So straightforward enough. The first question is, what is the probability of at least 10 errors, or 10 errors or more? So essentially what we do is we go to probability of x greater than or equal to 10, okay, and it's this line here, okay, and it's straightforward enough. The answer is 0.5487, okay. So a step I've just skipped is actually that we have quite a lot of tables tabulated in our book. So essentially what we have to do is take a while to actually make sure we have n equal to 100 and p equal to 0.9. So just search through it there. You should be able to navigate your way through it very quickly. So the second question is exactly 7 errors. Okay, so this value here is 0.8828. That's the probability of x greater than or equal to 7. Okay, now if we look below it, what we have there is the probability of x greater than or equal to 8. Okay, so it's essentially the difference between those two numbers gives us the probability of x equal to 7. So just think about the sample points are, this is for this particular case, probably x greater than or equal to 7. That means 7, 8, 9, 10, 11, 12, all the way up to 100 successes. For probably x greater than or equal to 8, that is 8, 9, 10, 11, and so on. So what is the difference between the two? That difference is the probability of x exactly equal to 7, and that's what we're interested in. Okay, so let's go down to our answer. Let's work it out down here below. So probability of x equal to 7 equals the probability of x greater than or equal to 7 minus the probability of x greater than or equal to 8, and that works out to be 0.0889. Okay, the final question asks us, what is the probability of being between 5 and 15 inclusively? Okay, so the sample points are 5, 6, 7, all the way up to 15. So what we want to exclude is 16, 17, all the way up to 100. So we want to exclude those, just so we get those specifically. So what we can do there, our approach here is find the probability of x greater than or equal to 5, and from that subtract the probability of x greater than or equal to 16. The probability of x greater than 16 is the probability of the sample points we want to exclude, 16, 17, all the way up to 100. So first off, the probability of 5, x greater than or equal to 5, is 0.9763. The probability of x greater than or equal to 16 is 0.0399. And we subtract one from the other, so it should be a fairly substantial number. And it is 0.9364. So just have it written here, 0.9364. So that's it. Straightforward enough. Key thing there is just actually being careful and mindful of the importance of sample points, the sample points you want to include and the sample points you want to exclude. Okay, we'll leave it there.